Today we're going to talk about negative exponents. The first thing we're going to look at just patterns of exponents. So you know that 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and 2 to the fourth is 16. If we're looking at exponents that are less than 1 and we go down to 0, -1, -2, -3, we want to look at our pattern from 16 to 8. From 16 to 8 we divided 16 by 2. From 8 to 4 we divided by 2. And from 4 to 2 we divided by 2. So if we're following the pattern, if we do 2 divided by 2, we'll get 1. If we follow it again and divide 1 by 2, we'll get 1/2. If we divide 1/2 by 2, we'll get 1/4. And if you divide 1/4 by 2, you get 1/8. If you notice, 4 is the same as 2 squared. So that's the same thing, 1 divided by 2 squared. And 8 is the same as 2 cubed. Okay, so let's look at 3. When we look at 3, 3 to the first is 3. 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81. Again, we look at the pattern. We see the pattern is they're decreasing by dividing by 3. So if we do 3 divided by 3, we get 1. We do 1 divided by 3, we get 1/3. If we do 1/3 divided by 3, we'll get 1/9. You split it into 3. And if you split 1/9 into 3, you'll get 1/27. And again, you see that 3 to the second, you can also write that as, or 9 is also 3 squared, and 27 is also 3 cubed. So we see that when you have a negative exponent, it mainly means you're going to divide by whatever that value is. So 2 squared is normally 4, but instead of it just being a regular 4, we're going to divide by 4, so we're going to get 1/4. So anytime you have a negative exponent, it really means to divide by that amount, I guess. So if we're looking at x's, x to the first is x to the first, x to the second, x to the second, so on. When you're moving down this thing, you're going to be dividing by x. So x to the first divided by x, and x divided by itself is going to be 1. 1 divided by x, or x to the 1 first, that negative exponent means to divide by that amount, so we're going to divide 1 by that amount. Here we're going to divide by x squared, and here we're going to divide by x cubed. So anytime you have a negative exponent, you put it in the denominator. This says anything to the 0 power is 1. And again, this isn't a great way to prove it to you, because if we looked at 0, if we did like 0 to the 0 power, 0 to the first, 0 to the second, 0 to the third. 0 to the third is 0, 0 to the second is 0, 0 to the first is 0. If we followed our pattern, we would have to be dividing by 0, and we have talked about multiple times how you can't divide by 0. You should ask Siri what is 0 divided by 0 and see what she says. It's kind of fun. Alright, so the next thing we're going to talk about is when we're simplifying, you never want to leave negative exponents. So if we have 2 squared, a to the -3rd, and b to the 7th, we want to simplify that to where we don't have a negative exponent, and we can already evaluate 2 squared. 2 squared is 4, but instead of putting a to the -3rd, that means you're going to divide by a cubed, and then b to the 7th gets to stay in the numerator, and that's your simplified expression. That's your simplified term. Here again, you have 3x cubed. Those are fine because you have positive exponents. These exponents are negative, so you have y to the 4th and z to the 5th that need to go in the denominator. We need to divide by y to the 4th and z to the 5th. Here, you have a 2 raised to the -3rd power, so that means that you'll have a 2 to the 3rd underneath the fraction. 2 to the 3rd is 8, so we'll have 8 on the bottom. You have n to the -2nd and m to the -3rd, so you'll have n squared and m cubed. That p to the 5th, since it's a positive exponent, needs to stay in the numerator, and so that's our simplified expression there. 5 squared is 25. Our y is also going to stay in the numerator because it doesn't have a negative. The x and the z are going to be in the denominator because both of those have negative exponents. You can leave it z to the first, or you can just leave it z. Either way is good. Here we got 3 to